Example 9. Find the critical numbers and intervals where the function is increasing and decreasing. So in this function we have a square root, and we have to make sure that whatever is inside of the square root is always going to be greater than or equal to 0, because you're not allowed to have a negative inside of a square root. Well, x squared plus 5 greater than or equal to 0. And if you move that negative 5 to the other side and think about this side is always going to be a positive or 0. This side is always going to be a negative. And a positive number or 0 is always greater than or equal to a negative. So there are no issues with the domain. The domain of this original function is negative infinity to positive infinity. So any number can be a part of the input values for this function. Now to take our derivative, the first thing we want to do is rewrite this square root with a 1/2 power. And then we want to take our derivative by doing the power rule. It's power times the base to the power minus 1. So 1/2 minus 1 is negative 1/2. Times the derivative of the base using the chain rule is 2x. I see I have a 2 factor on bottom and a 2 factor on top. So I end up with x times x squared plus 5 to the negative 1/2, which is x over x squared plus 5 to the 1/2. Now this can be 0 if this numerator, x, is equal to 0. So our critical number here is 0. So we're going to have to put that critical number on a number line and see what happens to the sign. So my critical number is 0, and my f prime of x is x divided by x squared plus 5 to the 1/2. Now remember, we said that the domain of this function was anything, so we can check anything to the left of 0 and to the right of 0. So I'm going to check a negative 5 on the left, so that's my test point on the left, and a positive 5 on the right. So if I do f prime of negative 5, I get negative 5 divided by negative 5 squared plus 5, all of that 1/2 power or square root. So that's negative 5 divided by 25 plus 5, and that's the square root, negative 5 over the square root of 30. Now this is a negative and this is a positive, so overall, while we don't really care so much about the precise number, we know that this region now is a negative, okay, until we get to 0. Now I'm going to check f prime of 5, and I'm going to get a positive 5 in my numerator this time, divided by 5 squared plus 5 to the 1/2, which is 5 over the square root of 30. So we have a positive over a positive this time, so that's going to be a positive. So this region is a positive. So in conclusion, what we can say is that this function is decreasing from negative infinity to 0. And the function is increasing from 0 to positive infinity.